Going to give me the count. Good morning or good afternoon, I guess, depending on where you are. Hopefully you are less frozen than those of us in Ohio at the moment. It was a whopping -2.
Yeah.
So it was entertaining. So I'm Ben Savage, the CEO of Veritas Automata. I've got Saurabh with me as well. You're going to see the adventures we have as we continue to dive into the different parts of AI at the moment in our podcast, Truth and Automation, The Deep Dive. As you will see that we've changed some of the mics up. So far, I have not broken anything this morning, which is unusual. So that does not mean something won't go wrong as we do this, because we do believe in MVPs and seeing what happens and how it all works. So I think the first thing we'll do, first getting ready for experiment, we've been continuing to play with the GPU server we set up. We've been continuing to look at some of the different models. You've heard me talk about our interest in small models as much as the large ones. So why don't you tell us which models we have while I get the screen shared, Saurabh?
Yeah, so today we'll be having another street fight bout with two smaller models, Llama 3.23b and the Phi 3.8b. Again, we are trying to see how the sizes of model determine how they are able to think through strategies and things like that. So I'm going to kick it off. It takes a second to load up the environment. It's similar to the last one we did, but just with a smaller model. And
what's interesting is these models were released probably about 6 months apart from each other. Phi 3 is a little bit older model, whereas Llama 3.23b came out about 3 months ago.
Right.
And do you remember which one is which here? Which color is which?
So the green one is Phi 3, and the red one is Llama.
Okay, so that wasn't looking too good for Phi 3 right there. It just took a... And we do see that some of these smaller ones, the battles go on a little longer than the fast ones. It takes them a little longer to make their strategic decisions, which is not a bad thing in the context of this game, whereas in a corporate environment, because you're dealing on a smaller data set, you can leverage more compute to go faster that way.
Correct. I think possibly because of the smaller size, it's not able to find nuanced strategy that the bigger might be able to see it much faster. So again, so I don't know who won that one. It didn't tell me.
You'll have to check your results.
Yeah, it doesn't tell me that. It was strange. Maybe it was a draw.
Oh, so I broke something finally today.
Well, it generally tells me either one of the two models, but it looks like they had a draw or something, which is interesting because we ran this few times, Well, that's the fun of having.
But I think that's what also goes to show as you look at this. These are non-deterministic, right?
Okay.
You'd probably run this 6 or 7 times as we were prepping for this, both to make sure it would basically work. And so we had an idea to go what to talk about. And here what we see is different results than we expected. Because I think in all the other battles, Phi 3 had won.
Yes, it did.
And in this case, we've got different results.
Maybe it's a draw. Who knows? But it's the fun things with LLM, the non-deterministic nature of it also is a part of the challenge of using this in a deterministic world, right? Going from, and we were thinking of talking about prompting kind of leads into that whole world that hey. What did you say in the morning? Prompt and pray. That's
well, that was an article, right? That was one we were reading. It's one we need to start creating a link repository from the different things.
Yeah.
But this was one from O'Reilly. It was called Prompt and Pray, right? It was the thesis of the article was a good prompt is not enough. It may not be deterministic and it may not be able to perform consistently because the way the models work.
Right.
So you may need to put other structure. You may need tool use or other things around it.
Yeah, I think back when the LLM was really getting popular, prompt engineering was one of the hottest job out there. Because that's one way to control it. But as the things mature, we're figuring it out. Prompt just itself is not enough. You need downstream guardrails to keep it in check. And like English language, it's not very deterministic how you say things, right? It could be multiple different ways of saying it, but you get to the end goal of communicating an idea across, right?
Yeah.
So think in equivalent terms in the LLM world, it is also trying to communicate an idea across, but it's finding a lot of other paths to do it. So
And I think I don't want to take away from people who are prompt engineers, right? Because it's still an important skill, learning how to ask these models questions. But it varies, right? Each time you change model, the way you prompt can be different between those two, significantly on the way it responds. Also, how do you go structure your prompts? So let's talk a little bit about that, because you and I have some different prompt approaches.
Yes.
I tend to go with pretty simple ones and build on them. I think you tend to take a more built-out approach.
So my approach typically has been around, treating the LLMs like a high school kid or an intern who needs a lot of guidance. So I would typically spell out step by step what it needs to do, and then also provide a bunch of examples along with the prompt. So that's how I've seen that they have, say, for example, you want an large language model to produce an output in form of a JSON or a structured output, so that you can take that, run different things downstreams. Maybe you are invoking an API call or something based on the output. So if that structure is not maintained, the downstream wouldn't be able to understand what to do with it, and the system would fail. So in those scenarios, having a structure in the prompt itself helps a lot. That's been my approach with it. Why don't you share yours?
So I tend to be simpler. Asking it a question, but not going into a lot of examples. But I'm not usually looking for structured output. I want to come back to that.
Yeah.
But it's asking a simple question, saying, provide this summary, or how do you help me do this? And then from that, iterating on that piece of content. Because what I find sometimes, if I ask it for too big a piece, I get a hallucination because it kind of loses its way, right? It doesn't know what to focus within the context, or it just isn't able to go understand it. And then you get some of the models back to the safeguards in some of them. Sometimes when you ask a model a question, it won't answer because it's got a protection around it. You may not be trying to do anything bad, but you've got to think about how do you ask the question in a broad way.
I think your approach makes a lot of sense. What benefit that it brings is that you are freeing up the context window, because all of these large language models have a limited context window. Some of the public ones, they have massive ones. You won't exhaust them that easily, but anything smaller, they are kind of limited to like 512, 128. As you get smaller, the context will shrink.
So let's remind people about two important things when we talk about LLMs. First, what do you define as a token?
Okay, so token, I would say, is a group of alphabets put together in a way that it makes more and more sense for LLM. It's not at an individual ABCD or alphabet level, but it's chunks of them. It could be even words at times.
It's almost like breaking a sentence down into phonetic elements, right? Where it's not, you're not breaking down the direct alphabet, you're breaking it into the sounds or the concepts.
Correct. Yeah, so that it can predict, instead of predicting every alphabet every time, it's predicting chunks, and and as it puts it together, it's easier for computational to do that and faster.
So then let's talk about context, because those two kind of go together, right? When you're talking about context is usually described in terms of tokens.
Right. So think of context window as how big of your plate is. As you look, you have a plate of food. You have a lot of things in it, and you are saying that, okay, fill up the plate with the rest of what you think would go along with the other items I have on my plate. It's a good way to think about it, but with largest model, those are massive. So you can put examples and other detailed instruction with it. But with smaller model, again, because it's smaller, the plates are smaller, so you can only fit so much into it, right? So simplistic prompting, it's helpful because it has a lot more room. It can fit it if it's its own answer into it. So that's the easy way to understand what a context is.
And so when we talk about like context, whatever, that was one of the big jumps from GPT-3 from OpenAI to GPT-4, right? As their context window went
massively up,
quadrupled or something like that. It went from like 25,000 to 150,000 tokens or something like that. So how do you think about that combination of token and context in prompting? Like we've talked a lot about RAG. Most business documents are going to be bigger than one of those context windows. Right. So how do you think about that kind of those 4 points, that kind of
Yeah,
thing that you
so
gotta
I think it's a
together?
very interesting question because you can't throw a massive law book at an RAG question and expect it to answer.
Yep.
The trick is how do you extract rightful pieces of information that would help you answer that questions in RAG. So yeah, business documents are massive. It could be thousands and thousands of pages, but if you have a secondary layer in it, that's the retrieval piece of it, is figuring it out. Hey, you want to look at volume 1 of that document or chapter 1 of this document. Your answer might be somewhere there, and then let the LLM figure out what the answer might be. It's a one way to do it. Again, it's kind of where you are kind of limiting the LLMs to be in certain spaces rather than go find something in the world kind of a setup, right? Yeah.
So I will come back to one more thing on RAG, and then we'll go back to the prompt engineering piece. I think that'll be interesting for folks. But when you think about a RAG, retrieval augmented generation, for those who don't remember from our previous podcast, or building a LLM into your application, you've got to think about how are you getting the data in where the model can go see it. How are you building your prompts, which are two different things as we were just talking about there.
Right.
And then how are you building your responses back, all of which have different things, right? And that's kind of back to what we're talking about structured data. I've seen one of the trends now is that people are building specific grammars or tool sets into the LLM or into their application to force the generation of that structured content.
Yeah, I think building the toolkit is really a cool idea because again, you can fine tune for without spending bank on it, but you will be able to embed a lot of those industry language into the LLM itself because if you get something vanilla LLM, it's trained on natural language from the internet. It may not contain your industry specific acronyms, so you don't be able to previously we were talking about the different names of the same drug. It may confuse when you are putting it if it doesn't know that this drug also is known as this, right? You don't want to put that in your prompting because it's going to be a dictionary in itself, right? So at that point, you want to fine tune it so it understands it and it frees up your token window so that you can put other interesting thing in it. So that I think that's an interesting direction where a lot of these things are heading towards. And again, towards the prompting side of the things, examples make quite a bit of differences, right? So you are a specific instruction that you want to stay within this family of pharmaceuticals that you want to answer questions around. So it goes hand in hand. That's where I would kind of leave it there.
Yeah. So because we talked about kind of simple and chaining prompts.
Yes.
You talked about more detailed prompts.
Yeah.
Where do you think of the idea? I've seen a couple of times people talk about the idea of chain of thought or chain of reasoning prompting.
So think of like you're interacting with a public large language model. You ask a question, it gives you back. You say, what do you think about this angle? Or as a human, you keep prompting ahead, and then it gets to an answer that you like. Think of automating that as a chain of thought, right? So you ask it, instead of answering that question, think of how you want to solve it and figure out the steps. And once it figures this out, you refeed that back. I'm trying to answer this. These are the steps I want to do. You're basically prompting back and forth till you get to a nice place and you have a seasoned answer rather than just going off what you provided in your prompt.
So how do you think that differs from some of the newest school models, right? With the GPT-4os, and we were just playing with DeepSeek R1 the other day. Those kind of have some of that built into the model itself.
Yeah, so the chain of thought came along when the large language models were just question and answer kind of prompting setup, right? So but over the years, people have been using chain of thought kind of an approach to do a lot of these things. So they are being built into what it's called logically thinking around it. But under the hood, it's doing that kind of, hey, if you get a question, think through this, come up with that. A lot of this tooling has already been built into the setup, and how the tooling is built. I think those are interesting differentiators between one model versus the others, because that's where a lot of the clever tooling can happen, and how you strategize how to think about a problem, right?
So I can see where if it's built into the model versus the structure of how you're inputting data, that could create some challenges, because if you need it to think maybe something very industry specific, right? Let's say we're in a chemical processing thing, and you need to go through a very specific thing, make sure you don't mix the wrong chemicals because that could be bad. that I can see as a challenge, because if the model's more freewheeling on its own,
Yeah.
it's an interesting idea to think of how you constrain that.
Yeah, I mean, you could, think of industrial experiment as you were asking question. It's recommending certain things, right? It's going through its own sandbox kind of environment where, it testing those out, saying that is this compatible with that chemical? It doesn't cause an whatever explosion or something like that before it answers you back. So again, large language model would become a piece of the entire system, but there would be other auxiliary systems supporting it, testing the answers, producing, feeding it back to it, where humans are doing it today. It doesn't make sense. Look at it. What about that? You forgot about that. And those systems could very easily be automated, but they can't be, packed into the one large language model because, again, it is trying to compete against a lot of different objectives at the same time. I don't think LLMs are there yet. Well, the larger ones are, but again, it becomes cost prohibitive to use a lot of the large ones if you're trying to solve a smaller problem.
Well, and I think it depends too, right? If you need to do it on your private or in a closed environment, or you want to use public data.
Correct. Yeah.
So interesting questions. We were kind of talking about just that, about small models versus large.
Yeah.
There's someone who asked about, when using RAG systems, how can we ensure content privacy? And I think there's a couple of different ways to go do that, right? So one, you've got to think about the broad context of a business. So if I go use OpenAI, or I use Azure, or I use AWS Bedrock, all of those have ways for me to license exclusive instances of the API and protect my corporate data. But that doesn't always protect individual files or build workflows that are going to be maintain typical business kind of problems, right? Because the challenge is, if I roll this tool out in a business, maybe not everyone has access to it. So then you get into data access management, which gets into how you build your application. That's not a prompting problem, to be very clear on that. That's how do you design your system. And if you're in like the Microsoft Azure, you can leverage the SharePoint permissions or your OneDrive permissions or your other document permissions that are already baked in there and tie that into a user's access. That's pretty easy from some stuff that we've done.
Yeah.
Or at least it's not a horrible nightmare.
I think with Azure, a lot of those things becomes more and more easy because they thought through a lot of these things. Especially, when you access control comes in, which we were experimenting and we built a POC on it, is that when it is retrieving a question and a context, it's also checking for the permission. Does he have access to the document before that retrieval happens, right? So it may answer certain very high level answer like what's the annual sales and something, but it don't go down what's my whatever R&D budget for that department, because that person doesn't have access to that piece of information. So the LLM, when it's being fed, the retrieval piece of it is not fed those proprietary or the confidential data that shouldn't be going to that.
And that's part of the building of the pipeline, right? And that's where you're building an ingest pipeline. At that point, you're creating all the vectors to be able to do the RAG. And at that point, you're tying permissions. So when someone goes to look for something, you can filter it out.
Correct.
You can do the same thing either on-prem or with the other tools if you want to do something where you don't have some of that Microsoft infrastructure. And we've built some of those POCs for customers as well, where you've got a little bit more tooling to go determine all those permissions, or you build into the tool some permissions management. Is probably the better way to describe it. So someone can go say, okay, we've ingested these documents, so Saurabh has access to these, Ben has access to these, and that's how we can go manage it. So it's always a solvable problem.
Right.
It can extend some time on the project because it adds some stuff in some environments. But then the last piece of this is, can your data be in a public environment, or does it have to be in a more controlled, whether it's in virtual servers or ecosystem you control on the cloud and is not publicly available, or it's in your own data centers? And that's where, back to why you hear me talk about small models so much, that's where it's really easy to go run those, because you don't need a ton of specialty hardware for a lot of business applications. I'm not going to say all, because there are some where, you're going to need your own fleet of A100s and H100s and all the compute, depending on the kind of what you need to go achieve. But that's all based on your business goals. So it's not necessarily a hard technical requirement. Even though as tech people, we're always going to say, give us more compute, give us more memory, give us more storage, and give us more GPUs.
Yeah, that's true. especially if the data doesn't need to leave the cloud, it could be hosted in your local large language model kind of a setup, right?
So, and there's some stuff that we're looking at is how do you build hybrid solutions where some of it happens locally and some of it happens in the cloud based on the type of data and the nature of the query.
Yeah, absolutely. I mean, one of the things we looked at is one of the very big upfront cost is ingesting your knowledge base and converting into vector, right? So how can we do that in a cost-effective way in a hybrid solution method? So yeah, it's an interesting domain for sure. Yeah.
Yeah. Sorry, I'm gonna have to grab a drink real quick.
Yeah. I mean, the space of RAG is still evolving, but the business case is very clear that it gets you the answers really quickly in a secure way. That the right person has access to the right answers, and not that's already been achieved today, and we've shown some of that in our POCs as well. It's doing really well. It is able to go through not just textual data, but tabular data. Think of like a 10K with a multi-tiered table and complex data. And we can probably show that demo probably the next time around. That it is able to read through that, understand because some of those, if you've seen any of the 10Ks, they are not easy to read. Their headers of those tables are way up in the top, and they have done some kind of nesting and all that stuff. Still to comprehend
and
that.
the problem sometimes too, and you see this in a lot of business documents, right, is you get a report from someone, and maybe they're not even giving you the Excel file or the tabular data with it. They're giving you a PDF that has some tabular data, maybe some graphs and things. And that's really easy for humans to do. But if you're trying to remember 2 years ago what was the performance of pie chart X that I saw, how do you go find that? And a traditional kind of search isn't going to find it. It's not going to surface in even most conventional RAG. You've got to build some special tools where you're really building that ingest pipeline out, and really that data categorization, right? To make sure that you're doing that tagging as you bring it in.
Yeah, it's also beyond tagging. What we were looking at is like the charts and the tables and bar charts and line charts and all. Can you ask a query just of that without using? It was an interesting experiment, and surprisingly, it did. It needed a lot of different Azure tools and some of our own coding involved in a lot of those stuff. But it was able to extract which a human would at the same level, which was kind of really, really cool. Because often people throw a chart without talking about it in the main part, especially PowerPoints.
That's what I was kind of hitting on. There's so much of business. And the challenge there is some of the biggest commercial models can do it okay. And they're going to be better than most of the open source models. But if you want to protect your data and run it either in your own environment or offline, you're going to think about how do you have to build some of these things to go do that ingest. The one thing I think we found is Azure has some really, really good pipelines for that for business users. But everything is equally solvable outside of that. And we've invested in building those tools so that when a customer comes to us and says that we need to go figure something out, we can go run that.
Yeah, I think it's getting very, very interesting, especially as the large language model goes multimodal, right? So it's not just stuck with natural language, but tabular data, image data, and media, and it's just evolving that because ultimately you can probably bring a lot of the multimodal data into a textual flat plane for
and that's an important thing for everyone to realize. A lot of the early GPTs or LLM models that people saw were not multimodal. They were only trained on large batches of text, and they didn't have the ability to do other things. In the last year and a half, you've seen more multimodal models come out where they're trained on a mix of usually images and text. Some I think are being now trained more on video. Well, we know some of the GPTs were trained on a bunch of video as well from OpenAI, and that builds the ability for the model to give responses, but it's also important to go select. So when you hear us talk about like Llama 3.1, 3.2, 3.3, sometimes there are different things, though, even within that same family of tools that they're trained on. So I think it's Llama 3.2 Vision is specifically the multimodal, whereas 3.3, you can sometimes get some visual aspects, but it wasn't trained quite as much on that.
Correct. I mean, the information that's out there is quite a bit of it is in text, but even larger portion is in a multimodal kind of a setup, right? So, the evolution from just the textual to a multimodal setup, it's coming. And, especially with the tool use beyond the large language model, you could have a AI system or a machine learning model looking for cancer cells within a scan or a record, right? And then have that detected, and why it is doing that through a large language model could become very, very interesting, because that way large language model doesn't have to be an expert every little detail thing, but breaking that task down into smaller model who are expert, but they may not be able to write a rock song. That makes sense.
It's also making sure that you've got that provability, that verifiability, right?
Yes.
That truth in automation where you need it, which is certain things you need to have a very deterministic method to go make that decision.
Right.
Whereas an LLM will not be deterministic. At least this is the way they're designed today.
Yes, yeah. I think the probabilistic nature of the LLM also plays into exploratory space of it, because if you're trying to solve something that is very deterministic, maybe LLM is not the right answer. You could have a hard-coded automation with a decision tree on an expert system, kind of switching like a train operator going to different tracks. But if you're trying to explore in a world where it's a strategy and nuanced thinking is needed, the probabilistic models do better, right? So having a combination, a hybrid of a deterministic model with a probabilistic model, mixed for a better setup. Right?
But I think, to your point too, sometimes that's where the interesting use cases sometimes come from with the LLM and the transformer type solutions, is leveraging that non-determinism.
Yeah.
Because I can't say the other word I was trying to pronounce. You can ask it some questions and you'll get some either really interesting or really random answers, because it is figuring out something that maybe you hadn't thought of, and it can be useful to trigger thoughts.
Yeah.
I'm not going to say go use that information directly without vetting it sometimes.
Yes.
But sometimes you can ask it a question and go see where it goes.
Right. So the best way to visualize that is it's whiteboarding with an LLM, right? So you was kind of bought into an idea. You may not be open to a lot of different other possibilities, right? Like in the last podcast, we were talking about how am I using it. It's this typical example. If I'm trying to find an answer, I would hit the Google prior to the whole LLM, and I would kind of get stuck to the first or second answer and not look down the search result if that gives me an answer, but it may not be the optimal path to where I want to go, right? So that the probabilistic nature of it helps you kind of look at a broader field for sure.
Well, and I think that also drives me in which tool I use, right? Because all LLMs are not the same; they're different. And Saurabh and I were talking earlier. I have on my laptop, I've got way too many LLMs on here. I think I've got 15 or 20 different flavors that I use for different experiments. And so most of the time, if I'm doing something that's more like a RAG, I'm looking at a document, I want to do something like that, I'll use one of the local ones because I don't want my data leaking out. I don't want other things. But if I need to ask a question about something that is current or something where maybe I would go to Google for, I might ask Google, but I might ask Perplexity or ChatGPT now because I know they've got some agents where they're doing their own ingest and crawling of the web because I know it's going to have more current data. So that's when you think about tool selection, right? That's going to be a reason why I'm going to go with someone's public APIs to go get something. Whereas if I'm going to throw up a document and say, what happens? I'm going to just run it local.
Yeah, absolutely. It's amazing to see a lot of these LLMs being able to run on a desktop or a laptop even today. It's a lot of those are getting smaller and smaller and distilled into more affordable places to run for sure.
So, sorry, I was looking at just a couple of the questions that came in. So one of the things, I think we talked a little bit about the ability to run AI local or run AI in the cloud or LLMs in the cloud or run hybrid. And so you're going to look at that. The first lens I look at it from is what is the business problem I'm solving? Am I trying to isolate data? Am I trying to protect data? Am I trying to, it's kind of like we were talking about, get some of those new features and functionality. I may need to drive certain kinds of prompts that way. And there's a whole new set of ecosystem tools that are coming out there that are just LLM routers that let you guide those prompts in different ways, depending on what that is. So you can build that into Apple. You can either build it purely into your application, or you can use one of those tools to solve it. So that's the first piece I think about. The next piece I think about really is data security. What data do I need to make sure absolutely never leaves my control and never gets exposed to the public, and what might need to stay? So that's where that might drive how I would choose that. And then the last piece is cost. It's going to be, you can create a better ROI over time if you own the hardware, or you can lock in a contract for specific private hardware versus calling someone else's API for many use cases. Not all.
Yeah.
There are some where if it's small enough, you're better off using fractional usage of someone else's. So that would be the third tier. And that's going to be different for every business use case and every company that you're trying to look for. So I'm not going to say there's a hard and fast rule from my perspective on how I would go do it, because I'm really looking at it from that business and kind of filtering it through those other lenses.
Yeah, I think the good way to kind of look at it is this: AI is not just one thing, or LLM is not one thing. It comes in various different flavors,
Yeah.
and especially because of the explosion of today's interest in LLM, it has ballooned into a lot of different variations and all. It's always figuring it out what fits where, and not trying to force a lot of the things, because some are designed to do certain things really well, but you pay a pretty penny for that, and whereas if you don't need that of a excavator to dig a tiny little hole, you might as well live with a shovel.
Well, think about projects that we work on.
Yeah.
Yeah, that you and I switch back and forth on a daily
Right.
basis, sometimes multiple times in the day. We've got one project where it's running image recognition in a model. It's a TF Lite model. It's a couple hundred K,
Yeah, yeah.
and you can run it directly at the edge in a camera,
Yes.
or on a custom board, or just on a Raspberry Pi, or we're running other things that are on a server with 128 gigs of RAM with dual Xenons and dual A6000s.
Yeah.
It covers. All that fits under what we call AI. It's a little bit of variation.
Yes. Yeah. It's when we talk about AI, it's not just one thing. It's how you prepare it, cut it, dice it, and present it in a way that makes sense, right? So, yeah.
So I want to come back to one thing we were talking about, because have you played much with the DeepSeek R1 yet?
Not yet, but
Okay.
yeah, I've heard a lot of chatter around how good it is around reasonably thinking and a lot of that
Because
stuff.
I was playing, I was sending you, and it was interesting because sometimes it was spot on, and sometimes I was noticing some little quirks. But again, right, with model selection, it's a model, it's out there. It's from I'm going to forget who the company is.
I think it's Alibaba's.
Is it Alibaba's?
Yeah.
I was trying to remember who was doing it, but it's under an MIT license, which is really cool, because even Llama has some constraints on it. But you get some quirks, and I've noticed it's pretty open about how it answers some questions, but other people, depending on how they're using it, have found there are some restrictions to what data it gives answers to.
Okay.
And I thought that was, I don't know, I was curious what your take on it was, because maybe this is why my computer was about to levitate, because I was running too many different things on it.
Yeah, so it's interesting because it's come from a different part of the world, right? So they have a different set of data set versus what we have over here, right? So and the way they train it is also slightly different than what historically has been done over here. So you see some quirks around when the output comes out. You might see a couple of symbols from a different language altogether kind of popping up in your output. So, you kind of hinted at, hey, is it thinking in a different language versus is ChatGPT thinking in a completely different language? Maybe it is what it is, because some of the system prompts maybe is written in a different language, so it's borrowing on that setup, because a lot of these have a lot of those instructional piece plays heavily. It's not just the data, how you train it, how you do the reinforcement learning in a lot of these situations also governs the final output.
So that's a term we haven't used before. So what is reinforcement learning?
So reinforcement learning is like, think of a simplistic child, like he's doing something good, you praise it. If he's doing something bad, you say, that's not good. So it's kind of reinforcing certain behaviors. That's the easy way to kind of think about it.
So that's kind of what leads to that human reinforcement learning, right?
Yes.
That's where there's a human kind of guiding the prompt. Is the response good or bad?
Exactly.
Right?
Yeah.
Because that was, tech has moved a long way, but like a year and a half ago when GPT-4 came out, that was like all the rage, right? Is that they built in that human reinforcement learning piece.
Correct. I mean, so that also varies from company to company or regions where it's being built, right? So you will see the nuances come through, all of that. So because underneath, it's all doing matrix multiplication and all that stuff, but what are the key differentiators is some amount of architecture is different, the data might be different, how they do the further downstream fine tuning is also kind kind of different, right?
So we probably need to come back to the matrix map multiplication and like Boolean and what is a neural net and all these core basics, because these drive how the tech works.
Yeah.
And the one thing I've become convinced with the longer I've dealt with tech is if you don't understand the fundamental logic the system applies. I want to be clear. You don't have to be able to do the math. You don't have to be able to program it, but you have to understand how the logic works. Because when you get an unusual response, you're now going to understand why did it do that.
Yeah.
So that's one we probably have to come back to.
Sure.
And I want to come back to the reinforcement learning, and I'm going to put you on the spot a little bit. Okay. How do you think that applies in RAG?
So you could, whenever you are getting an output from a RAG, you could rate it and then, kind of fine tune your retrieval process. One area is that hey, this is not the relevant answer, or the documents that you retrieve isn't right. How about this or that? That could become a feedback to your retriever itself. If you think about the retrieval side of the things, it's two things. One is you are converting the text into an high dimensional data. Is that conversion right model?
Yeah.
You could fine tune that model too. And then the algorithm where you have said that, hey, I'm going to retrieve it. How am I going to weight that? Okay, I retrieved 10 documents. This is high probability of it being a good and how bad. Those are all trainable networks or machine learning models. You could train that. And the other piece of it is that you're telling the LLM, hey, the retrieval was fine, but the way you formulated the answer wasn't right because you missed key pieces of information which was part of your retrieval. So it can, go and train those. Again, it comes into the place where you are kind of deviating from what a normal large language model look like and to more tailored towards your business enterprise, how you are, and that's why you're training it, customizing it, becomes your own rather than something you go off the shelf and buy it.
Well, and I think this is kind of back to the idea of prompt and pray, right? If you're just using an LLM by itself, you're always at a certain limit. So, but if you're building an enterprise tool that's going to use it, you're building in different layers that are helping drive, and you end up leveraging the goodness that is the LLM and its ability to deal with. That's what I liked about the article. It points out, and you pointed out, right? English is a weird language, and I'm saying this biased because that's my primary language. It is, and that's how, from a business perspective, we communicate. So that natural language piece is important, but there are so many different ways to say the same thing that having a tool that can understand that, because otherwise you've got to remember, for those of you who are old enough, who remembers how to do like the Boolean search terms in Google to actually use Google versus just asking a really long question, or Alta Vista or Ask Jeeves, like to get any answer you had to go do all the Boolean search terms and all that. Natural English matters because most people don't think about that, the world that way.
I mean, you mentioned that English language is if you think about how the language evolved, it is also probabilistic. There were multiple different words for explaining the same thing. That has evolved. Some took more precedence because it's also stats driven, right? More and more people start to say certain things certain way, and then that became the de facto definition for that word, right?
Have you ever read any of the books or heard a guy named John McWhorter speak?
No, I haven't.
He's a very interesting guy who talks about the history of the English language and like finding some of the mysteries on why there's some of the weirdness in it, because English is a mashup of a lot of different languages over its time.
Yeah, I mean, you can see that, right? So LLMs are kind of very early in the game. The way it very well clicked. I think the probabilistic aspect of the languages and the architecture makes it click very well because there are multiple different ways of expressing the same term. In English language, you have multiple ways of doing that. Maybe it's parallels in the LLM too, right? So expecting it to be deterministic, maybe you ask the question 3, 4, or 5 different people the same question, they will answer it same thing, right? I mean, it's a different way, but they will mean certain things. So maybe the best way to think about LLM is not what it's answering, but what is trying to answer, or what is the ultimate goal where he's taking it to you. It may be from different routes, but if it takes you to the right destination that you can get the right answers from it, maybe that could be the expectations with a lot of
and that's probably one of the biggest differences of LLMs versus what had come before it, right? Because a lot of what had come before it for natural language processing really had come out of translation. And there people were trying to create hard and fast rules and get very precise translations to automate that. And LLMs are a little bit more looser because they're based on how people write and how people talk. They're not based on a very trying to identify, this is exactly how it translate this into a different language.
I think I was having a conversation on the same topic with our mutual friend. He was talking about coding, right? We are using a lot of the large language models to code certain things. So the thing he pointed out that, hey, if you ask the same, solve this problem, it will solve in 5 or 6 different ways. But that's how the LLMs are designed. You can solve a problem using coding also multiple different ways. There's not a deterministic way. But what is deterministic is it able to solve it the way you want it, right? It's kind of like test-driven development, but for LLM kind of a setup. Maybe that's the way to think about it, right?
Yeah, well, and I think LLMs for coding are really interesting because that is, it's an artificial construct. There's way more rules and it's way more clearly defined. There's lots less. You don't have sarcasm in writing code.
Exactly.
Usually. In the comments, yes. In the code itself, no. But no, I was talking with the same friend. I think we're going to have him on, actually. I had lunch with him the other day. So I think we'll arrange for him to come on because he and I were talking about some of the same things. One of the articles that I had shared with him is, okay, so you do the initial prompt, but then you ask it 5 times to write better code, and each time it continues to improve the code.
Correct.
Sometimes.
Yes, sometimes. It's about branching, right? It's trying to think, okay, this is my starting point. How I'm going to make it a little bit better. So it's seeing things differently. So
But I think the other thing people have to remember with some of this is you still got to think about ways that you teach people how do the fundamental things work. This goes back to, we were at KubeCon in November, and we were talking there, and there was a gentleman from AWS who was talking about how this is going to abstract a lot of things. The problem is, though, is if you abstract stuff too much and you don't understand the core logic and the core way things work, when it breaks, you're not going to be able to fix it. So that gets to, okay, so I can have AI write perfect code.
Yeah.
Or at least okay code. We'll settle for okay code right now.
Yeah, okay.
But when it doesn't work, how do I debug it if I don't actually understand how the language works or the operating system works or the computer works or the network works? Because maybe it's not the code that's failing, it's something else in the stack. And I've got to go figure those pieces out. Or if you're dealing with something like Java, it's like, do I have my garbage collection set right? All that kind of funky stuff.
Yeah. Yeah, I think the coders, the jobs of the coders, again, a lot of it will be automated, but we'll still need people who understand it at a very deep level so that they can debug it better. You can copy paste stuff and throw it at, but it will take you down. It had happened to me multiple times in a route that it doesn't make sense, right? It will go down to a more and more like a root goal machine. It keeps on growing, and then you solve the problem, but it's not the right way to do it. So it's a useful tool for sure, but it's for automating, but you still need that supervision, the deep understanding of what are you really trying to solve for it to work really well. So
yeah, well, I would describe it in some ways, the importance of a systems architect and a systems understanding become more important, which are sometimes harder for people. It's the same thing like when you play with the image and the video tools. You're not the artist laying out or editing the pixels anymore. You're laying out the creative vision. And sometimes that can be harder for people to do in a clear way to describe it than it can be to actually just slap some duct tape and code together.
Yeah, I mean, there is a saying that the manager is as good as the instruction that person can give to his subordinates, right? So if you think of LLMs, it's how good of an instruction, which is AKA the prompting. If you are clear in your mind what you really want and you are able to articulate that in your thing, LLMs can become a really good helper in that aspect.
So I'm going to close out with one last question we got, which is, I think it's interesting because we're talking about small models. So how do you like to think about small models and the reinforcement and the goals for accuracy? So when we're applying them, how do we make sure they're going to be consistent in what they do and that we're kind of guiding them to the right place?
So with smallest model, fine-tuning is more cost-effective for sure. That's one of the things. You can make a smaller model more of an expert. So what you really want, this is just one part of the solution, is to make your LLM more and more expert around the domain you are trying to run it on. The second piece of it, and it doesn't work without the second piece, is having guardrails outside of LLMs, which are cross-checking. If you are doing, say, coding, having a sandbox environment where you quickly run this code with sample data, is it producing the output? Yes, then you pass it on. These are not very computationally intensive to build or do, but having that safety net right outside, because you have to say that this is a probabilistic model. It will make certain mistakes, but can we catch them early on and set it back?
It's the nature of the tech, I think. But the other thing is, a smaller model is going to have less probability, less total options to give you random probabilities. It's just a smaller number of parameters.
Yes.
And the other thing is, it makes it easier for you to self-host it or host it in a controlled manner,
Right.
so you don't have to worry about outside influence. And when I say about outside influence, that's not necessarily a negative. Someone could come up with a enhanced and a better model.
Mm-hmm.
But what that doesn't mean is you want to go use it in your business use case because it may change the way it responds.
Correct. Yeah.
And so a small model, one of those 3 billion parameter,
Yep.
you can easily host that on something in the cloud or something local that's completely in your infrastructure control. And it only changes when you update that piece, not when someone else wants to.
Absolutely. I think, this places where smaller model does really well, and there's spaces where your bigger models need to be there. If you are having things which need multimodal interfaces and things like that, smaller model you wouldn't cut it, basically, right? So it all depends on what you're trying to do.
Cool. Well, I'm going to end for today because we are at time. There were some demos we talked about last time we were going to do that we didn't get to because we kind of got on prompt, and we went down some interesting conversational trails. So we'll do those next time. I appreciate everyone joining us. We're always open to have a conversation with anyone if they have questions or would like to learn more or have a potential problem they think AI or ML can go solve, or just a question of what if and what would happen if we tried it. So thank you, Saurabh.
Thank you,
everyone.